This is a 3D representation of the radiation sensor. As you can see, most parts of the system have been painted white in order to reduce heating of internal components due to incident shortwave radiation. The only part of this system that has not been painted white is this handle. This is to be screwed onto any farm object at a weather station during the installation. For viewing results of the system, one shall use an LCD screen, that is for mobile applications in the field, and we have two ports here, one for power and then the other is a USB port. The USB port is for obtaining results at a weather station. That is, one just needs a USB cable plugged in here and onto a computer that has the data logging application that I developed, and with that he's able to monitor radiation readings throughout the day. System has a switch for turning on and off, and we have this transparent glass under which we have our three sensors. The first one is a photo transistor. This is for detecting incoming shortwave radiation. That is, it has ability of detecting from near ultraviolet, then visible light, and near infrared. The middle one is a temperature sensor, from which we obtain our temperature value of a particular time of the day, and with help of Stefan's law we are able to calculate the outgoing long wave radiation. These three photodiodes are being used to calculate the incoming long wave radiation, and two of them are pointing towards the sky at 45 degrees in opposite directions, and the middle one is pointing towards the sky at 90 degrees. This is to enable us to track the sun throughout the day, so that is why we have this part of the glass round and not flat like these other two. So at installation, these flat surfaces of the glass shall be made to point in the north-south direction. That is, if this part is pointing towards the north, then automatically this one will be pointing in the south, and the directions shall be achieved with help of this onboard compass. Down here we have an area in which we plug in our 9 volts battery supply for people who are to use the system in the field where there is no power, but it is more advisable for one to use a USB cable to supply power for better readings. This is the final prototype for my radiation sensor. Right here I do have my LCD display for taking readings in the field, just like we are here, and then Arduino prototyping board which has the microcontroller that I'm using for signal processing. Then I do have my circuit on this breadboard which I've soldered there. I have 3 photodiodes for measuring incoming long wave radiation, and then one temperature sensor that gives the temperature, which with the help of Stefan's law we use to calculate the outgoing long wave radiation. And I do have a phototransistor. This I'm using to obtain the incoming shortwave radiation. So the photodiodes can be seen to be at approximately 45 degrees, or they could as well be adjusted if required. Then right here we have a temperature sensor, and then the phototransistor. Yep. And that is generally the design. That's after LCD display. So next I'm going to try and connect the battery and try to see how our readings will be. So actually out here trying to take readings, and all readings of radiation are in units of watts per meter. So let me try to zoom in and see what the readings are right now. That is SW is standing for shortwave, and EI, that is standing for incoming long wave, which is right now 1.5 watts per meter, and EO, that is E naught, that is outgoing long wave radiation, which is 495.02 watts per meter right now, and T, that is standing for temperature, which is in Kelvin. T, yeah, which is right now 306.6 Kelvin. So that was it, trying to take readings using battery. So with the data cable connected, you can now look at how a data logger shall get the data. So the user first clicks to refresh, and then ports that are available are displayed. You select the one on top if you've just connected the device, then click start. And when you wish to stop, just click stop, and all data in the buffer is scanned through and displayed. So information is given in blocks. So temperature is red, and outgoing long wave radiation is also red, incoming long wave radiation, and then the short wave radiation. So whenever you meet these bars, means you've completed data for one reading, and now you can look at another block which is also another reading. So that is basically it. The user afterwards can decide to save the data for future reference and further analysis. So that's all.